the actual description so that you can follow along, because that's actually not been posted anywhere yet. I'm having a lot of fun with these, writing them up, drawing them up, getting solutions out, and then, you know, kind of highlighting some of the key features that you'll need when you write reach programs. Just like a full disclosure, like a lot of these, you know, I show these level 1 solutions and talk about these level 1 solutions. These are really just kind of boilerplate applications. Like we're looking at, you know, today we're going to look at a program I'm calling the Vault, right? What does the Vault do? Like, it shows us how to create, you know, we're creating our accounts in our test environment, and we're depositing a large amount of network tokens into the contract. And then we're allowing one person to say yes or no. What happens with those funds, right? Do they go to A or do they go to B, right? And I just want to, like, full disclosure, say that, you know, once we start getting into level 2s and level 3s, that's where you start to see some of these more like really robust applications that have all the features of reach. So while level 1 runs and is a reach application, there's a lot more, and that's why I recommend that you know, once you get comfortable with the level 1 solution, try to build level 2. You know, save level 1 somewhere, like on your GitHub, save all the code on your GitHub after it works, and then start level 2 and see if you can do that too, right? There are certain things that we implement in level 1 that are for testing environments, right? And I'll kind of touch on those as we go through them. Can we see my screen there?
Sure can.
All right, so let me get the link and I'll share it in the chat here. Okay, so that should link to a PDF for this challenge that I'm going to go over. Let me know if you have issues accessing that. It should be public. All right, so let's get started.
What's going on here?
Hey, Smokey, do you have a question?
No, I'm sorry. I didn't realize I wasn't on mute.
Oh, that's all right.
I'm having issues getting in my visual code open.
Technical difficulties. We're all experiencing technical difficulties. Okay, the Vault challenge, we're calling this one, right? General program description. Write a Vault program that functions like a dead man switch. If you're not familiar with a dead man switch, it's on, off, right? It should allow the deployer to deposit some large amount of tokens, right? It should then ask the deployer to press that switch. If the deployer presses the button, the contract returns the funds back to them. If they do not press the button, it transfers the funds to the attacher, right? Generally, this is what your program should do, right? There are 3 levels again, and you can only submit for the 1 level. And again, we recommend build level 1 first, save that code somewhere, move on to level 2. If you have time, you know, save level 2 code somewhere, work on level 3, right? A little warning about plagiarism. It doesn't do you any good to plagiarize. So all these should be your own work written from scratch. Remember, these programs are just trying to get you to start thinking about how we turn word problems into code solutions with Reach, right? So program requirements, right? We're just going to start walking through these program requirements. One thing that you can do is just kind of turn these into comments in your code if you like, right? The key bullet points here, and that'll help you kind of keep it all in one document. I'm going to pull it up on my other screen here so that I can do them both at the same time. But we're not going to be going through as much of the boilerplate stuff today. So first step it shows is start with reach init. So what is reach init? Let's first get a terminal open. Okay, we're in our reach folder. Now let's make a new Vault folder. Okay, you know, last time we created each one of these files and we wrote every little piece of the boilerplate from scratch. We're not going to do that this time. This time we're going to use this tool called reach init. What does reach init do? Reach init creates these two files for you, index.rsh, index.mjs. So let's get these files open and take a look at them. So this is boilerplate reach init file, right? This is the bare bones minimum of what you need for this to actually run, right? So here's your, and I like to have this actually in the back, maybe because I'm neurotic. So the backend file goes in the back, but here is just your bare bones boilerplate reach application. This is the front end, right? And you're seeing some console log statements. You're seeing, you know, your new test accounts. You're using the account handle to attach to the backend, and you're storing that in a CTC Alice, like a contract information constant, right? We're starting our backends, and then here's where the actual action is going to happen, right? So let's just run this and see. It should run already. Like when you run reach init, these files actually run. So you got to make sure to tell it which network to run on. Oops. And now let's see what this boilerplate outputs. Oops. Right. Hello, Alice and Bob, launching, starting backends. And then it should give us a goodbye, Alice and Bob. Right. So when you run reach init, you have two files that work, right? When you start kind of creating more reach projects and just trying to play around with the language, it's a really useful tool to just like get started and then try to implement the functionality that you're actually sort of aiming for. So I've been running projects here for probably too long, so this is just good practice. And I'm gonna run reach down here, and then we'll get started working through the bullet points here. What does reach down do? Remember, it sets down old Docker containers. You know, I probably have a few of these up from yesterday and some from this morning. Sometimes the images can get crossed up and kind of just have like odd behavior that you're not sure what the error is. So let's exit out of here. Okay, so we used reach init and we created this boilerplate file, right? It loaded the standard library for us. It imported the backend, right? It created a constant here on line 3 for the standard library for us to reference, right? Line 7 here is creating accounts for Alice and Bob, funding those new test accounts, right? Here again is the account handle. We're using that account handle to attach to the contract backend, and we're storing that in CTC Alice. And then we're using Bob's account handle to attach to the backend that is already attached by Alice, right? That Alice has already attached to, right? And then in here is where we're actually awaiting the promise or the action of these two participants. So what does our program requirements say here now? Okay, use 2 participants for the vol. Okay, well, the boilerplate did that for us, right? So now it says the deployer should pay the contract a large amount. And I'm not sure if you guys are noticing, but like I try to highlight these like keywords that are actual reach functions and such, just to kind of help you out when you're reading these. So fund this new test account with at least 5,000 network tokens. The idea here is like the vault is like, it's like an inheritance. What if me, Alice, had like, what if I had 5,000 algos to my name and it was like my inheritance for my grandkids or something, and I wanted to store that in a smart contract and then let that contract know, hey, either I'm here and I want my tokens back, or I'm not here and I want it to go to somebody else, right? So that's kind of the general idea. So we're going to fund this new test account with 5,000 network tokens. Why are we doing this, right? Well, if we look at the boilerplate here, right, you're seeing, and we see this in a lot of reach applications, right? So what I want you to do is break this out and take account Alice out of here and fund it with at least 5,000 tokens, right? So we're going to change this. Instead of 2 accounts, it's just going to be 1. And don't forget the S there. We're just going to create const account Bob and just fund him with the regular amount of tokens. And then for account Alice, here's where we said we want to fund this with at least 5,000 network tokens, right? So account Alice, remember we use new test account here. So we're using new test account and we want at least 5,000. Let's give it 6,000. But remember, we can't just say 6,000 because the network deals in micro algos. So we're going to parse 6,000 down. I'm sorry, not just micro algos, also way or micro units, I should say. Okay, and then we need to await that, right? So we have that same functionality that we're seeing here, just with more tokens, right? What's the difference? Well, this constant is already storing the value of the currency parsed, right? Here, we're parsing it right here. We're not creating a new constant for that. And we're sending 6,000 of those tokens. Okay, so now Alice has 6,000 tokens in her wallet. Now we need to pay those 6,000 tokens or a large amount of those 6,000, use any number you like. But if it's just a value that Alice is going to know about, well, that goes in Alice's interact interface, right? So let's look at the back end here. Well, if this is Alice's interact interface, what are we going to call this? I think I called it like inherit. And inherit, we're going to do 5,000 tokens, but remember we need to parse it. Oops, autocorrect. We're going to parse it, right? So we need to parse currency, and we're going to say 5,000 tokens, right? So in the back end, we've declared. Oh, I'm sorry, that's not accurate. Getting my files mixed up here. In the back end, we've declared that inherit is going to be a number, right? It's just going to be an unsigned integer. And remember, we just declare our data definitions back here. And then in the front is where we're going to say inherit. What is inherit? Well, inherit is the standard library parse currency, and it's 5,000 tokens, right? So now what have we done? We've declared that the inheritance is an integer, and we've declared that it's 5,000 tokens worth. Okay, well, now we need to pay that amount into the contract. How do we do that? Well, pay is a function that we use in Reach. So why don't we grab this information from the front here? Give me just a second. Okay, so we need Alice here, just Alice only, to do what? To grab this value, and let's just call it that. We're going to declassify it, remember, because it comes over hashed from the front end. And it's just called inherit, right? But it's in the front end, so we need to interact with inherit, right? So now A only is going to grab this value in a local step, right? In a local step. And again, this program is completely automated. Everything's happening autonomously here. If this was a real program, right here, we would probably ask Alice, how many tokens do you want to put in? But for this level 1 implementation, we're just gonna automate that to 5,000. So that's kind of what this functionality is doing here. Typically, we would allow the user to input any amount of tokens. Okay, well, we have that value. Now, if we're going to use this value, we need to publish, right? We also said that we want to pay that into the contract. So pay is actually going to send whatever's in value into the contract. So the contract should, after this line here, have 5,000 tokens in it, right? So what did our bullet point say? Pay the contract a large amount like an inheritance. Fund this account with at least 5,000 tokens. Okay, so we funded it with 6,000 and we paid 5,000 in, right? So now what's the next one? So of these two participants, Bob should then send a Boolean value to the back end to accept the terms to the vault. Okay, well, if you don't know Boolean, follow the link there. It's just true, false, typically. So create a function in the front end and return true to the back end. Again, this is us automating this action. If this happened in a real application, we'd probably ask Bob, do you accept these terms, right? So we're going to create a front end function to return a Boolean value. Okay, well, this sounds like something that just Bob is doing. So that's going to go in Bob's interact interface here, right? We're going to call it accept terms. What is it? Well, it's a function, right? We're going to pass it in the amount of tokens that Alice has declared. And then we're going to return that Boolean value. Okay, this is our backend. We're declaring accept terms as a function. It takes in an integer and returns a Boolean value. So now this is our front end. How do we actually make that happen, right? Well, we need to create that in Bob's interact object. So in Bob's interact object, we called it accept terms, remember? And we said it took in a number, right? And we said that that number was the amount of tokens that Alice has decided this contract is for. So what do we want this to do? Well, remember, we just want it to return true right now. We're automating this. You know, typically we would allow Bob to choose true or false. And then I also want to see a console message here that Bob has accepted these terms. Bob accepts terms of the vault, the program, the vault. For what? For, well, remember, we called it num. But it's going to come over in micro units, right? We parsed it down to send it to the back end. Well, now it's coming from the back end in micro units. We need to send it up, right? So that's a standard library function called format currency. And we're going to pass it in that number. Excellent. So now Bob should accept, you know, when Bob has this function called accept terms in the back end, and in the front end, here's what it does, right? Well, now we need to actually include that in our program steps, right? So Alice has told us about how much the contract is. She's paid that into the, actually paid that into the contract. And now we need Bob to accept the terms, right? So Bob only is going to do something, right? He's going to accept the terms, right? And we're passing it in that number, right? But remember, it's a front end function, so we're going to interact with it. And then it comes over hashed. So we're going to declassify it, right? And then we need to store that return value. Remember, it's going to return a Boolean. So let's store it in a constant here called terms. So we're calling accept terms. We're passing in value, and we're storing the result of that function in terms. Remember, in the front end, the result of that function is just to return true. So right now, this is a long-winded way to say that we hard-coded this constant to true, right? So now Bob needs to publish his decision. He needs to tell the blockchain about his decision, right? So let's go back to our sheet here. Bob should send a Boolean value to the backend to accept terms to the vault. Create that function in the front end and return true. This is us automating yes answer, then publish that bool. Okay, we've done that, right? Now, countdown timer. Create a constant value for a countdown timer, right? Well, if she's not going to push the button, we have to have some kind of countdown that states if she doesn't push the button after 2 days, we can execute the remainder of the code, right? This is a little bit different. We're just going to declare this constant, and we're going to tell both participants about it, right? Level 2 implementations start getting into actually using this countdown timer and you know, using it in a loop and kind of making it a little bit more real use case. But right now, we're just going to create a constant for that countdown timer, and then we're going to show it to each of our participants. So it says show this to each, right? And that links to the reach docs. And then this function should be part of both participants' shared functions, right? Well, they both need to see it. That means that it should be shared, right? So then we need to inherit those shared functions in the participant interact interface. Let's see what that looks like. So the first thing we said is it needs to be in their shared functions, right? Let's first create that constant. Let's just call it countdown. And let's say it's 20, right? And now we're going to create our shared functions. Now you can call this anything you like. I think the tutorial calls it player. I prefer to call it shared. I think that's exactly what it does, and it helps you to remember what it does. So all we're doing with this is showing them this countdown, right? We just want to show the countdown. So let's say it's show time, right? How much time are we allowing? It's a function. It's going to take in an unsigned, oh, that's not the right one. It's going to take in an unsigned integer, right? And then it's going to return a null value because we're just going to print this, right? Okay. Well, if we're saying this here, we also need to say that Alice can use these shared functions, right? Anything that both participants need to use should go in these shared functions. So then we can say here that Bob is also going to use these shared functions, right? Okay. So in the back end, we've declared what the definition looks like. We've inherited to both Alice and Bob. And now we need to define what that looks like in the front end. So let's go to the MJS file to the front end here, and let's create our shared, functions here. Okay, so let's do that. Yeah, let's do right after we attach there. How's that? So const shared, taking in no arguments. Right? What functions did we say were in here? Show time, right? So let's show time. It's going to take in an unsigned integer. We're just going to call it t for time. And then we're going to just log that to the console, right? We're going to come back to this here. We're going to come back to this so that we can show you parse int here. And I'll get more into this once I actually start getting you the output here. So, but spoiler alert, we need to parse the integer, right? Reach creates a big number object for these unsigned integers in the JavaScript representation of what we're calling unsigned integer here in the back end. The JavaScript representation of that is a big number object, right? And if you follow along to the bottom here, this will actually tell you why, right? But okay, so we're going to continue on with our countdown timer, right? So we've created our shared functions in the back, right? We've declared them, we've inherited them, and then in the front here, we're actually defining what it does. It just logs this to the front end, right? So now we need to show this. We actually need to execute this for each of our participants, right? And if you're going to inherit in the back end, you also need to inherit here, right? So they both can use this. Remember, this is just the interact object in the front here. So we're going to inherit the shared functions here as well. And now we need to actually invoke or move through this action, right? So that's going to happen in the back end, right? So if we're going to say, okay, well, he's accepted these terms, right? Now let's see what the countdown looks like. So remember I said each, right? Alice and Bob. What is each? Each just means A and B are going to do this both, but in their own local step, right? So if Alice and Bob are running different front ends, which they should be, two different screens, right? This will output to both screens, right? So each A and B, well, we need to show time, right? We need to pass it in our hard-coded countdown. But because it's a front-end function, we need to interact with it, right? So what is this going to do? This is going to interact with the front-end show time. It's going to pass in the number we've decided for the countdown, And then when it gets to the front end here, what is it actually going to do? It's just going to log that number. It's just going to show us the number, right? So have we done everything on that bullet point? Show this to each Alice and Bob's front end. This should be part of both participants' shared functions, and then be sure to inherit the shared functions in each participant interact interface. We've done that. So now let's create the actual functionality. Let's create the switch, right? This happens a lot in programming where you need a switch of some kind, right? 0, 1 works really well for that when we automate. So that's all we're doing here is we're automating a button, right? So this should be a front end function that you call from the back end, right? Use math.random to create a random number between 0 and 1, right? 0 is false, 1 is true, off, on, right? And then again, that's us automating this action for Alice. Now display that choice as a string to the console. Okay, I'm not here or I am still here. And then use this value to actually transfer funds in the back end. There's a lot to unpack here. So let's unpack this a little bit at a time. So let's start by, well, if Alice is the only one who needs this function, right? We know where that goes. That goes in Alice's interact interface, where we're just going to call it like get choice. We want to get Alice's choice on what she wants to do. So it's a function, right? It's going to take in no arguments. It's going to return us a Boolean value, true, false, right? Now we could keep our 0, 1 and pass the integer back, but I really wanted to use Boolean values just to kind of mix it up. We use integers a lot. So we're going to say get choice is a function that only Alice can use, and it's going to return us a Boolean value. So now in the front, let's go back to what that looks like, right? So Alice now needs to actually choose. How do we do that? Well, we called it get choice. We said it took in no arguments. And then this is where we're actually going to use our math random here, right? So if you're not familiar, math.random is a function that will return a random number for you between 0 and whatever you give it, right? So here's a 0 and 2. So that'll actually choose 0, any number between 0 and 2. And it deals in fractional numbers as well. So what we're going to do is tell it, give us a whole number. I just want whole numbers. Math.floor does that for us, right? Now, it'll actually give us just a 0, 1. It won't give us a 2. 2 is not an option here. So we're just gonna call this the choice, right? So we're automating this. We're automatically choosing 0 or 1 by this math random function choosing a 0 or 1 for us, and we're storing it in choice, right? And now, what did we say? Well, we want to return that choice to the back end, but we wanted to return it as a Boolean value. How can we in one line check what is in choice and then return two different things, right? This is the ternary operator. This is a shorthand if-else statement where we're saying if choice is 0, right? This is going to check this condition. Is choice 0? If yes, return false. If no, return true, right? You'll see this a ton. This is really useful. It helps save lines, headache, a whole bunch of stuff. So again, I like to console.log, and so we know what's going on. Alice's choice is, well, we need this to actually, what did we say? We said it needed to be a string, right? 0 prints I'm not here, 1 prints I'm still here. Okay, well, I think the best way to do that is probably in an array. So let's just create a small array of 2 options, right? So that's going to be choice array, we'll call that. And it's either I'm not here or I'm still here. And these are our 2 options, right? And you want to make sure you get these right because each number is going to correspond to the index 0, index 1, right? So make sure that you have those accurate, because now what we're going to do is we're going to come down here. We're going to say that Alice's choice is, and then we're going to pass choice into that choice array to return that index string. So how do we do that? Well, first we say choice array, and then sub whatever value is in choice, right? So if choice is 0, it'll give us index 0. If choice is 1, it'll give us index 1, right? So that is us automating this decision for Alice. Alice is choosing between 0 and 1 randomly, and then telling us about that choice, and then returning true or false based on that number, right? Excellent. So that is the automation of that, right? So now let's look at actually calling that, right? So we printed it, right? We're on this bullet here. We displayed this choice as a string to the console. Now let's use this value to transfer funds in the back end. Okay. So let's go to the back end. Let's go to the back end. So what do we need to happen here? We need Alice to decide, right? And we can do this after we show everybody what the contract length is. Let's scroll down a little bit here. Let's say Alice only needs to do what? She needs to do something. She needs to get choice, right? And that's a front end function, so we're going to interact with it, right? Remember, it comes over hashed, so we're going to declassify it, right? And then we need to store that value so that we can use it, right? And we'll call this still here, right? And this is just going to return or hold that Boolean value from Alice's choice. So we're going to call get choice. We're not passing it in anything, right? And then we're going to store the return of that and still here. Here, get choice returns false if 0, true if 1, right? So that's 0, she didn't push the button, 1, she pushed the button, right? So now we have that value stored, and we need to publish that value, right? We cannot use it until we publish it, right? And now we need to use this to create a transfer pattern, right? We need to use this to create a transfer pattern. What's this error telling me? Exit cannot be used in context. Consensus step must be in step or app init. You must commit first. Okay, well, we can do that. Thanks, Reach. So we're publishing that value. Now we're going to use it to create a transfer pattern, right? What are our two options? Well, remember, if still here is false, right, we're going to transfer everything to B. If still here is true, we're going to transfer everything to A, right? So if still here equals true, now there is shorthand for this, and I want to show you because I think it comes up a lot, and I think it confuses people, and it's really not complicated. So still here equals true, right? It's the same thing if I do this. If that's a Boolean value, this is just a true false value, it will check without the equals true equals false, right? So you can just say if still here, and what that really says is if still here equals true, right? So I'm going to leave it out, but no, that's what happens there, right? So if she's still here, transfer all of the value. Remember, we said it was right here. We paid that amount. Transfer all of the value to A, right? That's what we're calling Alice in the back end here, A. Else, that must mean still here is false. So let's transfer the value to B, right? So let's go back to our bullets. We said we use this value to transfer funds in the back end. True will transfer funds to Alice. False will transfer funds to Bob. We've done that. Okay, we're just about done here. We just need to wrap it up with some console messages. So show the balance of both participants before the contract. Display your fixed time after you set it, right? Well, we did that in a bullet up here. So this is just to kind of reiterate, but this will require you to pass that time from the back end to the front end. This will also require you to parse int. Why? Again, because the JavaScript representation of an unsigned integer in Reach is a big number object, and I'll show you that when we start getting some output here. So what do we really need to do? We just need to display balances. We've done this before. If not, we'll learn how to do it right now. So we're going to call it several times, which means we should probably create a function for it. Let's call it get balance. Yeah, let's call it the full thing, get balance. It's going to need to be async. It's going to take in who's calling it so that we can use that to grab their account balance. Remember, we need to format the currency, right? Await the standard library to retrieve the balance of whoever is calling the function. Right, so there's get balance, and it's absolutely spelled. I don't know what happened there. Balance of. Yeah, that's correct. I'm not sure what happened there. So now we have a function for get balance, right? And we wanted to check the balances before, right? So let's just log those to the console. Alice's balance before is, and we need to await the get balance and pass it in Alice's account. And then we're going to do the same thing for Bob. Still written as balance. Oh, balance. Yeah, it doesn't like that. Make sure you get your spelling right. It will not like it. Okay, so Bob's account balance before is, and let's do the same thing. Let's await the get balance function to return the balance of Bob's account. Okay, well, there's the befores. Where else did we say? Well, we wanted to check it at the end too, right? So when the program is over. So let's run it down here as well. And we can do a little bit of cheating here because we're just going to copy these, come down here and paste them, and then change that to after. Okay, so we've shown both account balances at the end of the program. We've displayed our fixed time after we set it with our each method, right? Okay, so let's see. We do one last look over here, make sure I didn't forget anything trivial, and hopefully it compiles and runs for us on the first try. I don't think I missed anything, but you don't usually think you missed anything until it yells at you. Okay, let's just give it a shot. Make sure we save our files. Save all. Okay, where are we at? We're in Vault 2, so let's cd into Vault 2. Show me the files that are there. Compile. Now this will tell us if there's any errors in our RSH file. Compile only checks your RSH file. And then let's reach run, see what it does. Oh, what does it do? It says missing reach connector mode. Now you can either export this environment variable, set it in your config file. I like to show it for these presentations. So let's export it to algo and then let's reach run. Okay, it's going to spin up a Docker container for us. What's going to happen? Oh, wait, okay. New test account is not defined. Oh, that's right, because that's a standard library function, right? So we need to call standard library first, right? So that was probably the one that I did without the boilerplate, right? Yep, there it is right there, line 9. So let's use this to debug here for a second. Index.mjs 9 points right at the line. It says await. Well, this isn't defined. We don't know what that is, right? Well, we know that it's because Nick forgot the standard library call. So now let's save that and let's try it again. Let's see what other errors we have. Now notice, remember we compiled, so we knew there was nothing wrong in the RSH file. You run, and that'll tell you if there's anything wrong in your MJS file. So let's run it again. Well, there's some good output. Alice's balance before, Bob's account balance before, Bob accepts the terms for the vault for 5,000. And Alice's choice is that I'm not here. So this should transfer all of that 5,000 to Bob. So here's the account balance, 6,000, right? Bob is accepting the terms of the vault for 5,000, right? Here are the actual, here's the deadline that we set, and we'll go into that here in a sec. And this is the automated choice. This time Alice chose, I'm not here, I can't push the button, right? So we're gonna take 5,000 from Alice's, or it actually comes out of the contract, right? Because as soon as she pays, the funds leave her account and go into the contract account, right? And now this is displaying after the transfer. So let's look at this big number here, right? So again, this is in this file here. So this will require you to parse int. Why? Right? Let's take a look. Why? These are the different types in reach, right? These are all the different types in reach. Well, it says that an unsigned integer is represented as a big number object, right? It's the JavaScript representation of each of these reach types is a big number. So let's find where we need to parse in, right? So I left a little comment there so we would know. So now if we parse the integer out of here, right? We know that t is a big number object. Its hex value is this, is big number true, right? Now what does it look like when we parse it? Should just be a number, 20. And that's the constant we set for it in the backend. Hopefully we get a different choice here for Bob or for Alice. Yeah, Alice says, I'm still here. So the money should go back to Alice now, right? There it is. Less the fee for publishes and deploying the contract. So that is the level 1 implementation of the vault, right? What does the vault do? It stores a large amount of network tokens from the deployer and then allows the deployer to act like a dead man switch. If they're still here, give me my money back. If they're not here, give it to somebody else. So level 2 implementations start getting into looping and interacting, right? Again, this program is completely automated. Everything happens automatically. We hard coded the choices, right? The level 2 would be allow interaction, allow Alice to input how many tokens she would like. Ask her for her choice. Ask Alice for the choice, right? Send that choice, whatever it is, to the backend, right? Ask Bob if he accepts the terms. If he doesn't, exit the program, right? This is all outlined here, and I'm not going to go too far into this, but this is all outlined in your level 2 implementation. And the focus here is going to be on creating this timeout, right? Creating an actual timeout function. So if Alice doesn't push the button, it times out. But then also using your preset countdown timer, right? And I want to make sure to call them different, right? Countdown timer as a condition for a loop, where if Alice is saying, I'm still here, that we only allow that to happen for so long, right? And at the end of that, it should transfer the funds back to Alice. And then Alice can decide if she wants to, if they want to go forward with another contract, right? So that is level 1 implementation of the vault. Thank you for coming in this morning, and any questions, and I'll take those now.